Area of regular polygons. A regular polygon is both equilateral and equiangular. An equilateral triangle is equiangular and regular. A square is equilateral, equiangular, and regular. A regular pentagon is equilateral and equiangular. A regular hexagon is equilateral and equiangular. A regular heptagon is equilateral and equiangular. A regular octagon is equilateral and equiangular. An equilateral triangle is both equilateral and equiangular. The intersection of the perpendicular bisectors of each side intersects at the circumcenter of the triangle. So here we have an equilateral triangle with the perpendicular bisectors of the sides, and they intersect right at the center of the triangle. Segments to vertices are also congruent. Any point on the perpendicular bisector of a segment is equidistant from the endpoints of the segment. The circle centered at the intersection of the perpendicular bisectors of the sides of a triangle with radius r, as indicated, is called the circumscribed circle. The circle is circumscribed about the triangle. The three vertices lie on the circle. C is called the circumcenter of the triangle. A square is both equilateral and equiangular. The intersection of the perpendicular bisectors of each side intersects at the circumcenter of the square. So here we have the perpendicular bisectors of the sides. Here we see the segments to vertices are congruent. And here we have the circumscribed circle. A regular pentagon is shown. Let's find the angles alpha, theta, and beta. Here we see the perpendicular bisectors of the sides. And here we have alpha, there we have theta. In the second diagram, we see the segments to vertices are congruent, and this angle here is beta. The alpha angle is called a central angle, and theta is called an interior angle of the pentagon. Finally, angle beta is half the interior angle. What is the measure of angle alpha, the measure of angle theta, and the measure of angle beta? All right, so each central angle is going to be 360 degrees divided by 5. So each one is going to be 72 degrees. Each interior angle is going to be 180 minus 72 degrees. These are supplementary angles. And then the angle beta here is half the interior angle, so 108 divided by 2 is 54 degrees. A regular pentagon is shown. How many of the right triangles shown below are there in the regular pentagon? All right, so we have one here. We have another one here, there, dun, 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 and 10. There are 10 of these right triangles in the pentagon.